All right, Bob, I think we should start. For those who have joined, great. For those who have not, well, they can look at this recording later. So, hope you're all doing fine, as I said. And before we start, let me introduce Bob. For those of you who don't know Bob, he's our guest speaker. Bob has over 30 years of experience in the EX world. He's a Comp EX instructor and also an instructor of the ICEX Comp PC scheme. Always get this difficult. And as an inspector, he's done part of his job to do inspection on plant, and is a member of the US UL STP committee. He works for a company. He's a owner of a company, ICEX, which sells all sorts of EX certified product. So it's very qualified to be with us today, and it will be running the webinar on our understanding the wall chart fundamental of EX. Correct, Bob?
No,
not the title right.
No. We're doing EX inspection.
Inspection. Sorry. Well, then I have wrong. You have the wrong title on the question and answer.
Uh-oh.
I was looking at the question. That doesn't sound right, but yeah, it's EX inspection. So let's go next. Well, what a good start today. I can see it's only 7 a.m. for me. So before we start, let me give you a few moments to introduce GMI, just a couple of minutes, what we do, why we do it, and so on. So GMI International designs, engineers, and manufactures a complete range of intrinsically safe and certified devices for all automation packages, from DCS to SCADA, PLC, IPS, and so on, in all the main industrial sectors such as petrochem, oil and gas, food and bev, mining, etc. We have over 40 years of experience, and we are very proud to manufacture our product 100% in our facility near Milan, Italy. On the other hand, we are global players, having presence in all the continents. With 10 now, by next year will be 12 direct sales offices, many distributors, about 200 people, very dedicated, very focused on our production, which is, very, well, you'll see later. We do many courses, IES courses, SEAL courses, cybersecurity courses. Now we do them online. Before they were done presence, but again, the same. Thousands of installations. Some of our customers are, well, before we get to customer, these are, well, we make safety products. Our products are designed to prevent explosion into a plant. And they are also designed to maintain availability of the plant. So they're very critical components. Therefore, we take a lot of effort to make them, super, how do we say, Bob? Trustworthy. So
reliable.
That reliable and resilient. So state-of-the-art technology we use. We have 100% product traceability. We do full testing on all our product using our highly automated manufacturing process. We extend 5 years warranty and 10 years availability guarantee. And we basically, here we say that we design IS product, therefore, we care for the environment we live in, we care for the people that use them, so we try to make them as best as possible. Next, and to do so, of course, you cannot take our word for it. So we have certifications, global certification. We have over 15 independent agencies have certified our product, our manufacturing facility, our design engineering facility. We have a bunch of safety management certification up to SEAL 3, and all the others that you can read there. Next, these are the products we manufacture: IS barrier, safety relays, with line monitoring, without line monitoring, with special applications, isolators, SEAL certified as well, power supplies, SEAL and EX certified. We have a multiplexer, temperature multiplexer, digital multiplexer, HART multiplexers, surge protection device, some loop indicator, and as I mentioned earlier, a division that runs functional safety and EX services, so courses and services. Next is a list of our customers, just a few, the main system vendors from ABB to Yokogawa, many EPCs. We are very proud to be able to supply our product to OEMs that install the equipment, such as a safety barrier, onto their drilling rig or their compressors, or in the field in very harsh condition, wellhead packages and so on. And we are in the AVL of many end user. I believe I ran my 2 bits here. Let's see next, Bob.
Yeah.
Okay, so now we are, the title here is correct, EX inspection. So what an inspector looking for, and who better than you, Bob, can, run this? I don't know, how many inspection have you done in your life?
A lot, but actually not as many as my colleague Wayne, but I've done quite a few here in the last couple of years. So.
Okay,
yeah.
Guys, before I let Bob talk, there is a way for you to communicate with us in case, we will run at the end of the webinar a question and answer section through the questions you have raised through the registration. On the other end, if you want to ask questions, you have a little box there, you say Q&A, just type in and we'll be able to see it. Great, Bob, go ahead.
All right, well, thank you, Paulo, and thank you all for joining us today, tonight, tomorrow, whenever we are. Thank you very much. This is the first time we've done this particular webinar, and we've done probably 5 or 6 different topics. And I wanted to throw this one out there because I realize that if you're familiar with GMI, you're probably familiar. You may be a design engineer, you may be a system integrator, and EX inspections are not necessarily something that you think about necessarily in your day-to-day life. But as Paulo mentioned, all of these products that are built, regardless GMI or whomever's products, you're spending a lot of money, you're spending a lot of time, and it's highly engineered, it's safety critical equipment. But the issue is that if it doesn't get installed properly, if it's not selected properly, that's when we start having issues. And so I want to share with you a little bit of the things that we as inspectors will actually do, because I think it's important for you, even though you may not be involved in inspections, to understand when that third-party inspector comes into your facility, or if you're looking to hire a third-party inspector, what are they going to want to do? What are the things that you should have available for those inspectors? But most importantly, if you're building, say, for example, packages, if you know the information ahead of time before those inspectors come in, guess what? The inspectors in the inspection process goes real quick, and it's usually a very simple process. So ultimately, if you know more about what the inspectors are looking for, hopefully it'll make it much more cost effective, and you can get your equipment out into the field a lot quicker and faster and cheaper and all that good stuff. So why do we have inspections, right? Well, obviously electrical installations in hazardous areas possess features specifically designed to render them suitable for operation in such atmospheres. So, and I can continue to read that, but basically the function of an EX inspection is really designed to catch problems and potential safety issues that are critical to the safe operations of the facility. We want to catch these problems before they become disasters, right? That's the key thing. We want to make sure that we're mitigating these problems before they become issues and ultimately result in disastrous situations. And one thing about that, there was actually a study that came out quite a few years ago talking about the number of faults or issues with electrical installations that are actually in industry today. And I've seen a couple different reports on this, but one of the ones, and it was actually put out by a UK organization, and I wish I had it. I don't have it, and I wish I knew exactly which one it was, but it basically estimated that something around 30 to 35% of all the EX installations or the equipment out there, there's an issue with. Now, some of these issues are pretty minor, but they're not in compliance, and some of them are pretty significant. And I can tell you from my own experience of inspecting electrical equipment and mechanical equipment, there are a lot of faults out there that we want to catch, and we need to do a better job because we don't want to have issues, like I said, like what you see there. So what standard do we follow when we're following and doing inspections? The good thing is in the world, pretty much everybody in the world is following some sort of variation of the IEC 60079-17 standard. So if you're involved in the EX business, you'll be very familiar. We've talked about the 60079 standards at length with some of the other webinars. The -17 standard is the one that deals with inspections and maintenance of EX equipment. It's not a very long standard. It's actually only about 50 or so pages long, but it's got some really good relevant information, which we're going to cover a little bit here in the next 45 minutes. In the United States, we've adopted this standard now as a UL 60079-17 standard. In Australia, they have their version, and other parts of the world also have versions of the 60079-17. The good thing is that the base information from the original IEC standard is pretty much identical. There are some variations, but if you understand the basics of the -17 as published by the IEC, you'll know a vast majority of what's really in the other standards. So that's really where we're going to spend some time on today. Now, there are some specific requirements that go above, and this is important if you're doing inspections, is that lots of times, when I go out and go see some equipment for the first time, I'm following the requirements of the -17 standard. However, clients will have specific detailed requirements that they will actually have published, or there will be other standards that they will follow as well. They'll have their specifications. You may have your specifications. We always need to understand that, because the -17 standard is basically the bare minimum. That's telling us the bare minimum of what we need to comply with in order to be safe. But of course, people can go above and beyond that. So it's important to understand what are the specifications or what additional standards might be there that we need to pay attention to. So before we do our inspections, what are the things that we really need to have? And this is our little check sheet, one that I've put together, but this is more or less kind of what everybody is going to be looking for, right? What are the client specifications? What are the country regulations? If I'm doing it in the UK, I'm following, BS 7671 wiring regulations in addition to, say, 60079-14, which is the design standard, or what is in the client specifications. Here's another important thing to understand: what grade of inspection that needs to be done. And we're going to talk about this a little bit further. The types of things that we need to have our BOM. We need to have a bill of materials. What is the equipment out there? We need to have drawings. We need to, if there's panels, we need to have access to drawings. We need to have access to the certificates. What are the relevant certificates? Is it ATEX? Is it IEC-EX? Is it something else? We need to have that documentation. We also have to have an EX register. Now, in many cases, I'll be perfectly honest, when I ask for this, a lot of people look at me like I'm like, what is that? Well, that is basically our kind of document, if you will, that has all the information about all of the particular pieces of equipment. It's kind of like our encyclopedia, if you will, of all the EX equipment, our EX register. And I'll show you what that looks like here a little bit. The other things we need to have are data sheets on the particular pieces of the equipment. Now, from the drawing standpoint or area classification, this is also an important thing to understand. What area or what zone, what category, which EPL is this equipment located in, right? A lot of times people will just say, hey, it's going into a zone 1 area, and that's all we'll know. It's like, well, that's not enough, because I also need to know what are the gas groups, what is the ambient temperature range, what is the T code requirement, is there any environmental issues, minimum IP ratings. The other thing we need to have is a listing of all the X conditions in the certificates. So we need to understand, that's why we need to have copies of the certificates to understand the special conditions for safe use. And then obviously, if there are any previous inspection schedules or records that were done. So sometimes if this is a new installation, there won't be, obviously. If this is a new skid package that's being built by a subcontractor, that won't exist. So we'll basically generate a lot of that information. Either the client will, or we will, or somebody needs to build that register and have all that information so that can be handed off to the end client. And that should be a living, breathing document that should stay up to date for the life cycle of the product. And again, if we don't have this information, right, it's like driving to an address you don't even know without a map, right? You're just wandering around in a circle. So we need to have this information before we do an EX inspection. So as I mentioned, the standard is the -17 standard, and there are types and levels or grades of inspections. So what you will hear the term quite often, the grades of inspections, there's basically 3 major grades of inspections. So there's called a visual inspection, there's a close inspection, and then there's a detailed inspection. So a visual inspection is just standing away from that piece of equipment and taking a look at it. You're just trying to get an overall feel for that piece of equipment. For example, if we see a flame-proof box, maybe it's missing a bolt, right? Or maybe there's some damage to the equipment. Maybe it's a broken lens on a light fitting or something of that. Or maybe somebody has drilled a hole into something. We're just trying to get an overall visual idea of what's there. We're not necessarily looking at the labels. We're just trying to get an overview. Is this product, if it's been in service for a long period of time, what's the effect of corrosion on this particular piece of equipment? After we do a visual inspection, then we go into what is called a close inspection. So the way we differentiate the difference between visual and close is using tools. So the moment we take a step ladder or we take a flashlight, now we're actually getting up close and personal to a piece of equipment. We're touching and feeling this piece of equipment. We're looking at the labels. We're checking for the tightness of the cable glands. Here's the important thing to understand. We can do visual and close without de-energizing the equipment. Again, when we're doing inspections, sometimes these are in factories where the equipment is not energized, so it's no big deal, but sometimes we're in a facility where there's flammable gases that are present in the environment. So when we do a visual and close inspection, we are not de-energizing, we are not opening up anything. The moment we start opening up something, we really are not in a visual or close. We have now moved into a detailed inspection. When we get into a detailed inspection, this is when we start looking at the interior of a piece of equipment, and we need to perform what is called a lockout tagout procedure. So the grades of inspection, there's visual, close, and detailed. Generally speaking, for new equipment, when we're doing a new installation, it's always a detailed inspection. But from a maintenance perspective, many times we'll just do a visual or close inspection and maybe do a little bit of detailed, and that gets into a little bit more information that we're going to cover here on this slide. So there's also types of inspections. So there's more or less 4 types that are defined in the -17 standard. There's what is called that initial inspection. So this is used to check that all selected type of protection of the equipment and the installation are appropriate. A periodic inspection, this is where we're doing it on a routine basis. So once the equipment is installed, it's in service, we want to periodically go and check our equipment at some point in time. This could be part of a normal maintenance routine, or it could be a dedicated periodic inspection, however it's done. Sample inspections are an inspection on a proportion of the equipment of the installation, or a proportion of the equipment and the installation. So the size and composition shall be determined. For example, if we're going to go into a facility and say they want us to do a full detailed inspection of all the EX equipment on, say, an offshore oil platform, well, there may be 700-800 different pieces of EX equipment, and realistically, you just cannot open up every single piece of equipment. So you might do a sample inspection, a sample detailed inspection. You may say, hey, look, we're going to pick out 5% of these particular items, 5% of the cable glands, 5% of the transmitters, 5% of the lights. When we go in and we do a sample inspection, we start seeing that, hey, all of these that we've looked at, they're all fine. We can safely say, hey, we're okay. But if we go in and we find out maybe 20 to 30 to 40% of those particular products, there's an issue, then we might expand that sample to include more, okay? And then there's also finally a continuous, and that's the inspection done by skilled personnel on a routine basis, okay? Detailed inspections are done during any repair, modification, or replacement work. So if we're doing any repairs to any EX equipment, it is expected that we do a detailed inspection on that piece of equipment. So within the Dash 17 standard, there are a number of inspection charts or guides which do provide us details of as to which and what should be inspected for each type of protection method and for each grade of inspection. Now, there are more or less 3 charts within the Dash 17 standard. There's one chart for EXD, E, and N, and actually TD for dust as well, dust protected equipment. There's a separate schedule specifically for intrinsic safety. And then there's also an inspection schedule for EXP, which is pressurized. Okay, so be aware of that. Other EX protection concepts are usually component level, but can follow one of these charts as a basis for inspections. So for example, if we had something that maybe was an EXO, oil filled, we would choose one of those inspection charts to use as a basis to inspect a piece of oil filled EXO equipment. But generally speaking, a lot of the other EX protection concepts are usually down at a component level, and they're part of an overall system, maybe part of an EXD panel or part of an EXE panel or so forth and so on. So here's an example. This is just a handful. This isn't the full inspection schedule, but this is just shows you what we're using. And if we actually kind of just look at this here, you'll see, for example, we have what is called A. This is for all equipment. As we look at these charts a little bit further, we'll see some other tabs. But what we're checking for, you'll see that we could find this if it's an EXD piece of equipment. We're going to want to check to see, is the equipment appropriate for the zone requirements? Well, it's a zone 1 area. Do we have zone 2 equipment? Check, yes or no. And we can do that inspection either as a detailed, close, or a visual inspection, right? Some of these, you can do these types of inspections as either a detailed or close. Some of these we can do them as only detailed. When we're talking about internal to the equipment itself, generally speaking, we can only find that information under a detailed inspection. So that's an important thing to remember. But these charts are very handy. When we teach the classes, either the Compex courses or the IEC EX COPC inspection courses, we give these charts out and we say use these because we have rigs set up with a bunch of EX equipment that people can come in, and we want you to try to find all the faults. Generally speaking, people will go in there and they'll find all the easy ones. You know, they might get 30 to 40, 50% just like this. But if you don't use these charts, I promise you, it'll make it very, very difficult. And even myself, as many inspections that I've done, I use these charts religiously, and they're helpful, they're handy. We have them in Excel. You can get them in all different kinds of formats, but they are fantastic charts and they really should be used. So the first one was general, and this is that same inspection table. The second one is installation. So this is where we're going to find things like, are the glands appropriate? Is the cable appropriate? So forth and so on. And again, these are not all of the boxes. I've only picked out just a handful of the items on here. There's about, I think, something around 45 to 50 different little line items that we would check for a particular piece of equipment. And again, depending on the grade of inspection, we're going to use anywhere we see a check mark, we're going to want to we're going to take a look at that and make sure that that's something that we check out. So there's also, like I said, there's a table just like this for intrinsic safety, and there's a table like this also for pressurized. So the important thing to note here is, remember this: you have these columns are applying to EXD equipment. These columns will apply to EXE equipment, and these columns will apply to EXN type equipment. So we want to make sure that we're staying in the right columns, right? So we don't have to use all those columns, and we just want to make sure. And again, if we're doing a detailed inspection for EXD equipment, we're going to spend our time on this first row. So conducting an inspection, right? It requires careful consideration. What is the knowledge, skill, the competence of the inspector? And what is the skill, knowledge of the people, maybe your client representative, the person that's with you? Sometimes we have a client representative who is with us and wants to see everything that we're doing, which is great. And here's one thing I would always highlight too: the more knowledge, if you're involved, maybe you're not doing the inspections, but you're maybe having an inspector come in, it's important to understand and have as much knowledge about your installation. So, because I can tell you right now, there are inspectors that have gone out there, and I'll get emails or I'll get a text or I'll get a phone call from somebody who will tell me, hey, this inspector is saying this, and I'll go, what? I don't understand that. So the more knowledge you have, it's not to put the inspector on their back foot or to challenge them, but it's always good to make sure that, hey, if an inspector is telling you, hey, this is an issue, ask them why, and ask them to give the information. Where does it say that in the standard? Where does it say that in the specification? Not to get argumentative, but to basically say, hey, look, I really want to learn, right? The scope of the inspection, as we talked about, the type and grade inspections, again, the documentation, availability of the facility personnel to assist, right? Sometimes we'll do inspections that'll be us. They'll just leave us on our own. Many times, some companies insist on having a person with you, and that's fine. That's great. The one thing you always have to be careful with when you're doing inspections, though, is that if you are by yourself and you're doing this type of stuff, especially if you're doing a detailed inspection, if something is wrong, something's broken or something like that, then they can come back at you and say, hey, you're responsible for that. So I do know inspectors, and there's times when I'll do this as well. I will not actually open up anything. I will have the field personnel actually open up the equipment. And again, we want to be able to de-energize, lock out, tag out. We might need a gas-free permit, access to the equipment to be inspected. Sometimes we're inspecting light fittings. It's very difficult to get up on scaffolding. Sometimes it's nearly impossible, right? The type of the equipment to be inspected, and certainly the environmental conditions. So here's a key thing: safety is utmost priority. Do not compromise the safety if you're an inspector by using equipment within a hazardous area which is not suitable. Things like just a general purpose camera, key fobs, computers, general purpose computers, opening energized equipment in a hazardous location without a gas-free permit, operating any of the controls without facility personnel present, allowing unsafe practices of any kind or allowing unsafe equipment to operate. And here's the important thing: not recording anything you believe may be incorrect or unsafe. It's always wise, and I was told this by a very wise inspector many years ago. He always told me, if you believe that it's a fault, then write it down. You can always go back and double check and look at some documentation, look at the standard, find out if it's really right or wrong. But if there's any doubt, go ahead and write it down. You can always come back to it later. So we have our first poll question.
We have a poll question. We want to make sure you guys are awake and listening like I have been doing so far. So we ask a question for you. Which one of these is not a grade on inspection? Visual, initial, close, or detail? to Bob before the webinar, so I don't have the answer.
You weren't paying attention.
But I was paying attention, yes. And I think I have, well, I cannot give it away. So a few moments for you guys to reply, and then we'll see if you've been paying attention. Bob, as you talk, I was thinking, in the training you do, it would make sense not only for an inspector to be trained, but also for, an end user or the person on the other side.
Absolutely.
Because, just be competent makes sense in both hands,
It does. Actually, I'll tell you, I talked to a gentleman today, one of my students that I trained a couple years ago, and he basically had that exact same scenario not yesterday. Today is Tuesday. Today is Wednesday. On Monday, when I talked to him, he had an inspector in his facility, and he just wanted to call and brag about the fact that he felt he knew more than the inspector. So, but his inspector said that, everything looked really good, and, but they knew enough to know what the inspector was looking for. So you're right. The more information, the more knowledge you have, the better you will be.
Here's the result. I don't think it's correct, but I don't know, Bob. We have 80% of our guests that reply initial.
That is correct. So
right. Well, then I was wrong. I thought.
If we go back to our charts, we have detailed, close, and visual, right? Those are grades of inspections.
Yeah.
So initial is actually a type of inspection, right? Initial, periodic, sample, and continuous are type of inspections. Visual, close, and detailed are grades of inspections. So, yeah.
Very good, guys. You've been doing very good. Okay.
All right.
Okay, be aware, there'll be another couple of these throughout the webinar, so pay attention.
Pay attention. Okay, so now we'll get into a little bit more fun, if you will, and we have a question. Actually, I'll answer this a little bit later. We have a question with regards to putting holes into EXP panels into zone 2 areas. So we'll talk about that here in a little bit. So without actually having you guys all chime in and everything else, I'm just going to go through these slides and just look at this and maybe think to yourself, what are some of the faults? And it should be painfully obvious to you that the big fault here is obviously missing bolts, right? So we see that obviously there's no bolts on this enclosure. We're missing them here, we're missing here, so forth and so on. And they've obviously taken a piece of some sort of wire or something like that, or a steel coat hanger, and closed this up, right? So the other thing here is that obviously the label is down here. Looking at this, it may be illegible. Without cleaning it up, we'd have to do some digging on this to find out whether or not it's in good condition. But realistically, with an enclosure like that, when we get into a detailed inspection, I would expect that a lot of the stuff on the inside is not really in good shape. But this would be something that we should be able to see as a visual inspection, right? So it's a pretty obvious issue. Now, this is a not so obvious issue. But there's a lot of parts in the world that people will use cable shrouds over cable glands. And first off, this was a big thing in the UK many years ago. Actually, when Shell was developing the Brent field, they started putting shrouds on cable glands. And what they found is actually when they went back, excuse me, shrouds were actually holding the salt water inside the gland, next to the gland, and the gland would actually deteriorate. So shrouds are very effective of covering up defects. Now, the big issue is that this is actually Teflon tape on a threaded entry, and Teflon tape is not allowed. So anytime that we see Teflon tape, that's a big no-no, because that's a flame path. We need to have a metal-to-metal surface. Now, using thread lubricant is acceptable, but anytime that we see tape on glands, that is definitely a no-no. And that would be something difficult to tell depending on where that shroud is. And many times when we're doing inspections, EX equipment should be inspected at a maximum interval of 3 years, no longer than 3 years. So if we're going to put shrouds on cable glands, then inspect or expect an inspector to come in and remove those shrouds sometime in the next 3 years. And they're very difficult to reinstall. So I definitely recommend that people do not use shrouds, use a higher quality cable gland, and make sure you don't use Teflon tape. Excuse me.
You okay, Bob?
Yeah, I am. I just got choked up a little bit. So this is another pretty common fault that we will see. And this is something that we would see under a visual inspection, right? And by the way, a lot of people that we teach in the class, sometimes they get hung up, well, is this a visual or close? Well, some people have good eyesight and some people are taller, some people are shorter. It's not really that important to understand the differentiation between what somebody can find as a visual fault or a close fault. Some people can read labels from a long ways away. I need glasses to be able to see the labels nowadays. But something like this is pretty obvious. This is a traveling plug that's been installed in a Flameproof transmitter, and that had actually been in service for a couple years. And yeah, unfortunately, that was like that. And that's not uncommon. Now, this is an interesting one because this is a transmitter or some sort of device that has, if you notice there, look very closely, those are actually plastic cable glands. So plastic cable glands are not EXD. They may be EXE, increased safety. Now, this box, just by looking at it, you say, well, that looks like a flame-proof box, and it actually is. So the intent is to make sure that the gland matches up the protection concept of the housing, if you will. So immediately you might think that this is a fault. However, this may not be a fault if in fact it was being used under intrinsic safety. So that's why we have to understand and we have to realize, do you have a descriptive system document? How is this device installed? Is it IS? Is it not IS? I would suspect that this is not IS because it doesn't have blue cable or any markings on this cable telling us that this is an intrinsically safe circuit. So that is definitely a fault and something that we would want to make sure that we highlight. Okay, going to our next one here. Now, this is a label that's not uncommon to see. And this can get really confusing to a lot of people. And we've had a webinar on understanding labels, so I won't spend all that much time on this. But if we notice here, we actually have, in this case, we have an ATEX certificate right there. We have an ATEX certificate right there. We have reference an ATEX certificate right there. And we reference an ATEX certificate right there. This is all the same product. But under this certificate, this product is marked EXNA. Under this certificate, this product is marked EXIA. In this certificate is also marked EXIA. And this certificate is for EXD installations. Important to understand, how is this product being installed? Is it being installed as an EXD piece of equipment? Is it being installed intrinsically safe? Is it being installed as a non-arcing device in a zone 2 area? So we have to make sure that we understand what certificate, what cert is it that we're actually trying to evaluate this for. And if we don't know that, then again, we really can't make an evaluation on whether or not this product is suitable, because all of those certificates, and by the way, I mentioned this very early on, very briefly, but this certificate, this certificate, this certificate, and this certificate all has an X at the end of it. That X means that there's a special condition for safe use for the installation of this product, meaning that we don't know what it says for this. Where we're going to find that information is actually within the certificate itself. So in order to do a detailed inspection or a visual or close inspection, really a close or detailed inspection, we need to know what that certificate means and what that information is. So therefore we can make a determination, again, whether or not it's suitable for the application and it's been installed properly. So what is the fault here? Obviously, this is a gland in which the barrier gland compound is not properly puttied up, if you will. There's gaps, so this would definitely be a fault. Now, we would not find this fault under a visual or close inspection. We would only find this as a detailed inspection. One of the things that we tell our students when they're doing inspections is do not open up any gland, especially if anything is energized. The moment we start opening up a gland and we have something that's arcing or sparking, then we've compromised the EX protection. So it's okay to check gland tightness, but we do not want to actually disassemble a gland until we're doing a detailed inspection and we've de-energized that panel, and possibly also need to have a gas-free permit as well. So it's important to inspect those glands to make sure that those compounds have actually been set. Now, this is just an example of some wiring that's going into some GMI products, right? So we have some wires that are just flying out there. We have obviously some little, we have some stray wires. So generally speaking, we would put bootlace ferrules on all of these. We'd want to make sure that those are nice, so we don't have any excess wiring, because there's minimum distance requirements between these conductors. We'd want to make sure that we do something suitable with these two little cables that are just sitting out here. Having them like that, that's not suitable. And of course, we want to do something with the armor. We need to do something with this shield. We can't just let it sit like this. So we do start looking closely at some of the wiring that's actually being done as well. One of the things that we don't really do when we're doing an EX inspection is that we don't look at the functionality of maybe how this product is working. We don't really care how it's programmed, a PLC or anything like that, if it's actually working. What we are concerned with is this an EX issue? That's really our major concern. So sometimes we can get confused or go down in the weeds worrying about components on the inside, when really we should be looking at what is it about this particular installation is an EX issue, as opposed to just doing, say, a factory acceptance test or something like that. So the fault here is obviously the label is very, very difficult to read. This is one of the biggest beefs that I have with manufacturers. And as Paulo said, we sell a lot of EX equipment. We sell boxes, we sell lighting, we sell GMI, we sell all different kinds of products. And one of the first things, whenever I talk to a vendor that wants us to sell their products, I always want to look at their labels, because a lot of manufacturers will have these little phenolic labels that will look very, very nice in a nice, clean environment. But the moment you put them into a chemical plant or in an offshore oil platform, they disappear in a very short period of time. So when we find that there's issues with labels at this point, we need to see about trying to get back to the manufacturer and about getting a new label, or at least having some documentation that will provide us information about this product. And we would find this fault typically under a close inspection. Now, sometimes it's an environmental condition. So this is a light fitting, a zone 2 light fitting, in which obviously there was water getting on the inside of this, and it seemed to burn out the capacitor, and we have a lot of corrosion. So the biggest issue is here is the fact that we have a lot of corrosion, which could affect, we could have shorting, certainly with water sitting on the inside of that certainly could short out and create an explosion. That happens to be an EXNR light, so it's not flame proof. So that could definitely be an issue. So there's a lot of water ingress and corrosion. And we would typically find this issue under a detailed inspection. The moment that we're going inside of equipment, this is where we start finding these faults.
Okay, as we mentioned, we're gonna have another question for you, another poll. Here it is. What standard do we follow for EX inspection? Whether it's 79-14 or -1, -10, -1 or -17?
Yeah, and while you guys are doing that, I'll try to answer the question. There was a question that was asked about making additional holes into EX pressurized panels into zone 2 areas. So generally speaking, you can add holes to EXE enclosures, increase safety. You can generally add holes to EXP enclosures. You cannot add holes to flame-proof enclosures. Now, with that being said, you would always want to check with the manufacturer of whoever EXP pressurized panel it is to find out from the manufacturer. But I know generally speaking with the EXP pressurized panel manufacturers, typically they're a sheet metal box. They will allow you to punch holes, but you always have to check with the manufacturer before you just go out and start doing that. So always check with the manufacturer.
Great, Bob. Okay, so let's end our poll. I'll show you the result. We have a great majority answering -17. I would have done the same. And what about -1?
So -1 is the standard for flame-proof enclosures or flame-proof products. The -14 standard, that's the design standard, okay? The 10-1 is the area classification standard for gases and vapors. So -17 is the correct answer. So you guys are paying attention. Awesome.
Very good.
Awesome. All right. So this one is a little bit one of those, okay, what do we do here? This is actually a scratch on a flange. Now, if you've seen some of the videos where you see that they damage a flange and then they'll set off a gas explosion and you see a big explosion, that does happen. And I used to work for a manufacturer in which we used to do those types of tests, and we'd scratch the flanges or damage the flame pass, and you could actually get flame propagation. So obviously this is an issue. We would want to take a look at this, and probably in this particular instance, this is a judgment call. You know, I could look at it in a couple different ways, because it's not going all the way from one side of the flange to the other. You could argue that, okay, it's only contained right there, but it is still a damage to the flange. So you would find that under a detailed inspection. Now this one here, it's maybe a little bit difficult to see, but hopefully you see this. This is actually water that's sitting on the inside of these enclosures right here. So obviously, hopefully these were not energized at some particular point in time into this motor. So we have a lot of issues here. These are both flame-proof boxes. This happens to be a threaded flame-proof box. This happens to be a spigot type design flame-proof box. So obviously water ingress is a big issue. Certainly we'd want to take a look at the flanges here and certainly the threads here, but at this particular point in time, it may be too far gone. Get the water out and maybe start over. Again, cable glands. And cable glands, by the way, are usually one of the biggest issues that we see where a lot of faults lie, either the misapplication of cable glands or not installing them correctly. So here's a very simple example. We start looking at the gland. Again, we would not find this as a visual or close, but when we got into a detailed inspection, we start backing off the back nuts to check a gland. Guess what? We see that the armor is not attached to the armor ring. And if you notice here, we have these glands right here in the front in which the shroud has been removed. This has been pulled back. But guess what? We have shrouds here, we have shrouds here, we have shrouds here. If I was doing this inspection, and this was not one that I did, I just found this picture, but I can guarantee you all those shrouds would have been removed and every single one of those glands would be inspected to make sure. because when you're opening them up and you see all 3 glands right there without the armor being installed, I can safely say that probably none of those glands have been properly installed. So we want to make sure that we're installing those glands properly. Again, cable glands, this is looking on the inside of a flame-proof box. So where somebody has actually taken putty compound and packed it around core cables, use some liquid type as well. Again, now the issue is right here. This may be safe, right? And this very well could be safe. It looks as if it's probably a pretty good seal. These are all pretty good seals. But this one here, we would never be able to remove this cable out of this if we ever had any issues, because that's going to be rock hard. There's going to be an issue that's there. Barrier glands typically have a union capability that they can be disassembled, but in this particular instance, there's no way that that's going to be able to be disassembled. And again, we would find this issue doing a detailed inspection. Now, here's something that's a little bit not uncommon, but it is something you can see quite a bit. We see this quite a bit in the US, unfortunately, especially with companies that are not as familiar with EX. If you notice at the very back of these certificates right here, this has a U at the end of it. This one has a U at the end of it. This is their ATEX certificate. This is the IEC EX certificate. If it has, I mentioned an X, that's a special condition. That means it's okay. We just need to know what that special condition is. If a product has a U, that means it's a component. Now, a component can never, ever be used like that, as is. This means that somebody bought a box and got an empty box and then populated it with terminals themselves and then said, here we go. The problem is with that enclosure is not certified as a complete assembly. There's a couple hints that will tell you that information besides the U. One thing that you're missing on this is that there is no T code. There is no T code. I don't see anything there. If you notice that, the reason why you don't find a T code on this is because we don't know, the manufacturer didn't know what actually was going on the inside of this box. So when you see a U, that means it's a component. That means it cannot be installed as is. And in this particular instance, the manufacturer or the skid package builder had to go back to the manufacturer. The manufacturer had to send out new labels and actually refurbish the box, put additional terminals in, and do all that good stuff. So you would find this under a close inspection. Now this one here, this actually may or may not be a fault. It's difficult to tell, but this flange, if you will, looks like it has some sort of what is called like a copper slip, which is a lubricating thread lubricant, if you will, that has copper. And that's perfectly acceptable to put on there. But the flange itself looks like it might be a little bit dicey. So we'd want to be concerned about that. So again, this would be something that we would find as a visual fault. The other thing is what you see down here at the very bottom. These are definitely, we cannot just leave connection points floating like that. They should be landed into unused terminals, or we should cap those with some sort of heat shrink or insulating cap. We can't just leave them floating around like that. So that would be, again, under a detailed inspection. The fault here is pretty obvious. This is actually missing a seal fitting or a stopper box. So this is actually a big maintenance issue. And this was actually in service when this was inspected. Actually, this was an inspection I did on a barge that actually exploded and 2 people were killed. The US Coast Guard ended up doing, they called us in to do the EX inspection. That wasn't actually the issue. That did not cause the issue. It was another issue, but we found that while we were doing the inspection. So obviously that's something that we would typically find as a visual fault. This one's a little bit maybe more difficult to see, but what we see here is that the gasket has obviously come out of the groove and it's gotten pinched, right? So the issue is people will ask, okay, what do I do in this scenario? Generally speaking, what you would want to do is go back to the manufacturer and ask them for a replacement gasket. The important thing to note with gaskets on flameproof boxes, we don't want to just put gaskets and just put a gasket on a flameproof box, because that potentially defeats the whole purpose of a flameproof box and the property and how it works. However, if it came with a machine groove like what you see on that box lid right there, it was obviously designed for a gasket to be put into place. So the ideal situation, temporarily, what I told the client to do was cut off, in effect, the gasket at this point and cut off the gasket at this point. So remove it out of this area, remove this, and then ultimately replace that gasket. Because, okay, we don't have a gasket here, but now we don't have a gasket in the flange. So that's not a safety critical issue if we remove that. If we don't have a gasket there, yes, it may not meet the high IP rating that you require, but at least it'll be safe. Now this one, let me do this real quick. Clear my drawing.
Oh,
this is the panel line.
We are running very late, so you keep that in mind.
Yep. Sorry. Yep. I'll zip through this real quick. So what we have here, this is the important thing to note on this. There may or may not be faults with this, but if we don't have a drawing to understand exactly what's supposed to be in this box, then we can't really determine whether or not this is truly safe. So that's the important thing to understand with flameproof boxes. Now I mentioned about the register. This is an example of a register that we should have, and this will have the relevant information, the certificate information. If there is any X condition, any information that we should find, this should also be on this register, and it should be available within the facility. Now, some tools available for inspections, which are very handy. There are Zone 1 tablets, there are RFID tags, there are tag readers, bar readers, and some of the software that's available out there to be able to automate a lot of your inspections. So a lot of this stuff is available and it's fantastic.
So, Bob, as I was saying, we're running to an hour. If our guests are willing to stay with us, and you are also, we can continue for a little bit. Let me ask you one more question, guys. Which one of these protection methods does not have an inspection schedules chart? But it's flame-proof, increased safety, encapsulation, pressurized? While you guys answer, let me ask you about these charts. You provide the charts, or they are in the standards?
They're in the standards. They're in the -17 standard. But I have those same charts that we built and put into an Excel spreadsheet that we give out to people. So if you want, I can send it to you, Paulo, and you can certainly send those to people if you'd like a copy of it.
You guys let us know. Of course, if you be coming to one of Bob's courses, for sure, training class, I mean.
Yeah, absolutely.
Getting the charts. Let me throw, I'm not 100% sure, but I think we did not spoke about encapsulation when we were looking at the charts.
I think you're correct. That is correct. Encapsulation, there is not a inspection schedule for that. So there is.
There is 70% of our guests have answered correctly.
That is correct. So.
Okay, well, I don't know how much longer you have the webinar going for.
Yeah, there's really, I have just this, and then we had some questions that were brought up that we can bring up, but just a couple slides. So again, when in doubt, these are just some of the key points. If you think it's a fault, write it down, right? The other thing, become competent. Go through an EX competency course to understand more. The IEC EX Certificate of Personnel Competency is a great program. We teach that one. That's a fantastic program. Realize you don't know everything. I do this all the time. Don't be arrogant. Make sure that you're humble. Be willing to listen. And again, just because you've seen it all before, I promise you, you'd face something you probably hadn't seen before. Don't let outside influences affect your judgment, right? Excuse me, one of the last ones there, even though you may not be officially an inspector, do it, right? I mean, if you see some EX equipment and you see something that you think is wrong, or even if there's an issue, bring it to somebody's attention, because the more people that we have looking at equipment, making sure that we're staying on top of this, the better, the safer we'll all be. And lastly, stay on top of your game. The standards change, and so you always need to stay up to date with the latest developments and the requirements in EX, right? And I just like this chart, so. And again, we're always as strong as the weakest link. So be as don't let you
don't be the weakest link. Yes.
Don't be the weakest link.
Don't be the weakest link.
You wanna bring up the last ones?
Yeah, let me do so. Let me try to share the presentation.
We just have like 5 more minutes. A couple questions that some people had asked when they registered that I wrote.
I think you're looking at it, right? The EX inspection question and answer. I changed the title while you were talking because I had a wrong title on there. So the first question we got is what is the role of the inspector or quality control during engineering and design construction phases of the project?
Yeah, that's a great question because usually the inspector gets involved at the very end. But really the inspector should have a say early on. There's a project that I'm working on currently, or maybe working on with a client here for a big project that's going on in the Gulf of Mexico. And we've proposed to them, hey, allow us to be involved with some of the third-party vendors that you've got, making sure that their documentation is right, doing all of that due diligence. So yes, it's really important. A lot of times it gets forgotten. It's usually kind of like at the last minute, those inspectors start coming in and then they start finding all the issues. If you can catch those issues early, then it's so much more cost effective, so much easier to fix all those problems before they become big issues.
Sounds correct. So another question we got through our registration was EX reclaim repair equipment. What are the requirements for those?
Yeah.
Are there any requirements? Yeah, I imagine so. Huh?
Yeah, there is. So the one standard that we reference within this is the IEC 60079-19 standard. So this has been around for about 11 years now. And there's actually what is called an IEC EX service certified service facility. And this is specifically around rebuilding EX equipment. So there are a lot of requirements that go into becoming a certified service facility. People must be competent. The facility must be audited. They must have a QA, QAN process and all that good stuff. I think the next slide on this, Paulo, there's actually 2 different labels that can be put on repaired equipment. You have one that's repaired in accordance with the type of protection, but with sufficient evidence of full compliance of the drawing. It should actually say without sufficient evidence of full compliance with the drawing. That's the triangle in a square. That means it's repaired in accordance with the scheduled drawing or manufacturer's specification. So this is where you take a very high dollar piece of EX equipment and you want to get it repaired. You don't want to spend $20,000, $40,000, $50,000 on a new big drive motor. You can take it to one of these service facilities and they'll actually do a refurbishment on that. And these are the types of labels that you would actually find. And the details are all in -19.
Great, Bob. What about mechanical equipment inspection required under 80079?
Yeah, so right now it's not there. There is no inspection standard for mechanical equipment. However, I expect that they're going to either update the -17 standard to address mechanical equipment, or there might be a new 80079 standard specifically around inspections for mechanical equipment. So it doesn't exist right now, but yeah.
Should.
It should. It will. It's coming.
So how about an old EX approved high pressure cleaning machine was built in 2013. Can I get approved for use in 2021? Meaning, can I use it today?
Yeah, potentially, yes. So the IEC allows equipment that's built to the latest standard, plus one back to be acceptable to be used in a new installation. Now, the ATEX directive requires what is called state of the art. So state of the art is you should really be in compliance to the latest standard, right? But it ultimately does come down to the regulations. However, generally, if the equipment is good condition, was supplied after 2013, but has been in service, it'd still be acceptable to use today. It's not obviously a requirement to replace EX equipment with new equipment once the standard change. However, if that product, if it was built in 2013 and it's been sitting on a shelf or something like that, you would probably have to go through some sort of gap analysis, which could be done in conjunction with an EX testing lab or a notified body to make sure that it's compliant to the latest standards.
Yeah, if you cannot put into a market a product that has been, out of date standard, but if you had been using it, otherwise we would have to replace most of the equipment out there because the standards keep changing and changing and changing. Getting more and more strict, but also safer. Yep. Okay, how often does EX equipment needs to be inspected? I believe you answered this question through the webinar.
I think I did, yeah. So 3 years is basically every piece of EX equipment should be inspected at some point in time. Doesn't mean a detailed inspection, but it should be inspected at some point in time. Now, movable equipment, handheld equipment shall be visually checked before each use. All equipment shall be submitted to a close inspection every 12 months. And again, that's for handheld equipment. Enclosures that are frequently opened, such as a battery enclosure, shall be given a detailed inspection every 6 months.
6 months, wow.
6 months. So if that could be any enclosure. So if you're opening up an enclosure in a facility that's housing a bunch of zone 2 components, it's a EXNA enclosure, but you're opening it up, then you should do a detailed inspection every 6 months on that panel.
Wow. So inspection are required on a regular basis.
On a regular basis.
What are the potential sources of ignition for non-electrical equipment, so mechanical stuff, that I should be aware of?
Yeah, it's basically the same stuff, if you will, that electrical equipment. I mean, but it's obviously different types of equipment, but hot surfaces, hot particles, mechanically generated sparks, stray currents, static, exothermic reactions, shock waves. There's all different kinds of things that are potential ignition sources. And these are spelled out in the 80079-36 standards.
This brings us back to the previous question, we do need, a chart to be able to do inspection on mechanical equipment because it can fail just as electrical. Can have a lot of issues.
And some of the biggest causes of major industrial accidents have actually come from things like bearings. Bearing failures on conveyor belts, they heat up, they get locked, what have you, and there's all different kinds of mechanical issues that have caused major industrial accidents. So that's why mechanical is becoming so important.
I can remember that a few years back there was ATEX directive that came into place about the mechanics of it, not
the mechanical stuff.
There is an electronic device, but I mean you have to make sure it does not build up electrostatic charges and so on.
Yeah, the European standards actually came out before the IEC standards, so they were the EN 13653 standards, and they've been around since the mid 2000s, and then the IEC adopted them here in the last 4 or 5 years now. So now they're known as the 80079-36 and 37 standards.
So, well, guys, we always get this question in our registration process. We are interested in something other than what we're going to talk about. So we invite you to look at our schedule, online schedule. You can also view the registration of all our webinars through our YouTube channels. And now I'm supposed to launch latest poll, if I can find it. There we go. We asking you how we did. Launch this poll, or basically how Bob did. Don't look at me, you know, I'm just...
If it was good, it was me. If it was bad, it was Paulo. So.
Exactly. And we thank you guys for being with us way over an hour. We are into
10 minutes.
It's time for you to go to bed, for me to get some coffee and breakfast. And for you guys, go to your job or whatever else you guys have up to. And keep in mind, safety is, critical, is important for not only, your work, but for your life and the life of the people you care about. I mean,
and I hope this webinar was informative. I know it may or may not apply to what a lot you do, but it's certainly a very important, sometimes overlooked function. So hopefully this gave you a little bit of insight into the inspection world.
And thank you for the 100% excellent. So Bob, great job as usual.
Thank you.
Let me do one more slide here. So you have our contact details. You can you can contact us. You will be getting a copy of the presentation for those who have registered, and you can always ask questions to me about later on. Thank you, Bob, again. Thanks for the great job.
Thank you, Paulo. Thank you, everybody.
Safe. And
talk
to you soon. Good night. Good night, guys.
Good morning. Good night.
Good morning. Ciao.